Hi gang, this is Colin Edwards. I'm working on a series of YouTube tutorials on how to use R as a biologist and as a scientist. And before I get into the more complicated tools, I wanted to give some context on how functions in R work, because they're one of the building blocks for everything else that I'll be talking about. I find it easy to think about programming in terms of nouns and verbs. So when we have some variable, or we might call it an object, that's a noun. And when we have a function, that is a verb. So if we think about simply talking in English, we have sentences with all kinds of varieties of complexity. So when we think about talking in English, we might think about sort of a whole range of complexities, some sentences with no nouns and some with many. So as a simple example, you might say something like run, or you might say something like Colin, run, or you might say something a little bit more elaborate. Colin, run to the ice cream truck. Now, I'm not an English teacher, but if we look at each of these sentences, we can see that there is a verb in each case. And in some cases, in the first case we have just the verb. In the second case we have a verb and a noun. And in the third case we have actually several nouns. Oh, let's, to be consistent, let's put a box around that verb. And so similarly, when we're programming in R, sometimes our functions require objects, variables, and other times they don't. So let's start with some of the simplest functions in R, and I can kind of talk to you about the anatomy of a function. A simple example of a function is one that gives us the current date and time. It's called sys.time. When we write out a function in R, we're going to give the name of the function, and then we tell R that it's a function with this open parentheses at the end of the name, and then we have to close that parentheses afterwards, and we'll get into what might be in the middle with some more complicated functions. But this is all that it takes to tell R to do a thing. We've given it our verb, our instruction. This is equivalent to this first sentence. And if we run it, we can see that it does something. We've given it instructions that it follows. Another function that you may be familiar with that doesn't require any arguments at all is called getWD. This is the get working directory function. And we can see that my current working directory is in my documents. Now, while you can technically have a sentence with only a verb in it, and you can have a function that doesn't require any arguments, any variables, oftentimes you want to be applying whatever instructions you're giving to something. As a simple example, let's try taking the square root of something. So the square root function is a function. So we've got our name, we've got our open parentheses. But inside of it, we have to tell R what it is that we want to take the square root of. In this case, let's take the square root of 9. And so we've given it a variable. This is equivalent to our Colin run sentence. Single variable, single noun, in addition to our verb. Now, if we look at the documentation, actually backing up slightly, if ever you want to know how a function works in R, you can type into the console a question mark followed by the function's name, and it will pull up the documentation. So if we look at the documentation here, we can actually see that it is identified with an X. So anytime that we give a variable to a function, when we're identifying it as one of the nouns that we want that verb applied to, so to speak, it is called an argument. And the way the function is written, R is labeling each of those arguments. So here it is using the label of X, so the X argument is 9. If we don't give it a label, R just identifies it by location. So R is expecting a single argument with the square root function. We give it a single argument, and so it knows that X is equal to 9 here. It's totally fine in these simple cases not to label the arguments, but as functions get more complicated, it can be useful and then sometimes even necessary to label the arguments. So I want to walk us through the plot function, which is a really nice example of taking multiple arguments and dealing with optional arguments. But before we plot something, we actually have to have a vector of data to plot. So I'm actually going to talk just a little bit about the concatenate function. Some functions can take multiple arguments, and a common one that's a little bit weird is called concatenate, which is shortened to C when we are programming. And that takes any number of arguments and it stitches them together into a single vector. So 1, 4, 5, 2, and 5 are each separate numeric objects, and now they are a complete vector. So let's assign vals1 to have that value. Cool, so now we have a vector, vals1, and we can give that to the plot function. So at its simplest, plot takes a single argument, which is what to plot on the y-axis. So on the x-axis, it is just numbering the items. So this is the first item in vals1, this is the second item in vals1. And on the y-axis, we can see that it's plotting the height based on those values. But plot is a much more complicated function, and it can take many, many more arguments. So as a simple example, let's give it both x and y values to plot. So I'm going to make a variable called vals2, which will be a vector. For simplicity, I'm going to make sure that all of the values are less than 1. That way it'll be really easy to tell which of our vectors we're looking at any given time. Cool, so now we have vals1 and vals2. And if we give them both to plot, vals1 and vals2, it gives us a very different plot. So now our x-axis is this first vector, and our y-axis is the second vector. And if we look at the documentation on plot, which is the default scatter plot function, we can look at the argument list and we can see that the first argument is x and the second argument is y, but we've got this weird equal sign and some stuff after it, and then we see this long list of additional arguments. So as far as R knows, we've given it 2 arguments, and so it is assuming that the 2 arguments we've given it are the first and the second arguments, and so the first one must be x and the second one must be y. I sometimes get these confused, and so if you want to, you can explicitly label them as x equals vals1 and y equals vals2. That doesn't change our plot at all. And the useful thing here is once you label them, R no longer cares what order they're in. It was only using the order because it didn't have explicit labels for those arguments. So if I run the function like this, our plot still looks the same. As a rule of thumb, it's a really good idea to leave the arguments in the order of the function, such that if you took away the labels, the function would still operate the same way. That's just good practice so that you don't confuse yourself. So when we look back at the documentation, we saw some weird stuff here. And the first weird piece is that we had this y equals null. So many functions in R take optional arguments. And in this case, even y is an optional argument. So if you look at documentation, anytime that an argument is listed with an equal sign and then something after it, that is an optional argument. And if you don't define it, for example, in this case, then R is going to, let's go back to that help file, then R is going to set all of these other pieces equal to whatever the default is. In the case of the plot function, when y is equal to null, it actually treats the whole plotting very differently. But in other cases, for example, the type equals p, this is short for points. We could give it the optional argument type equals L for line, and we've changed the way that our plot functions. A much more common case would be if we were plotting both x and y, say y equals vals2, so there's our plot. Oftentimes we want to change the x and the y labels to be something a little bit more meaningful. For example, maybe x equals height and y equals weight. So, x lab. So xlab and ylab are optional arguments that are tweaking the way that the function works. Now it's really important at this point to note something. So if I run this, it works, and we see that height and weight have replaced the default labels. So with x and with y, we didn't have to actually identify the arguments. R just looked at the order. But if we look at the help file again, the xlab and ylab arguments are way the heck over here. And so if we were basing this on order, R would say, the first argument must be x, the second argument must be y, the third argument must be type, and the fourth argument must be xlim. And that's not at all what we want. We're trying to leave most of the optional arguments to their defaults. And for that reason, we have to explicitly identify what it is that we're trying to change. And that's why these two are labeled. As an aside, I usually find that if I'm giving a function more than about 2 or 3 arguments, sometimes even more than 1, I will usually label the arguments just for readability, even if I know the order and I know I'm putting them in there correctly, because I might forget, but also someone else might not know the order that the arguments are supposed to go in. Okay, so that's the basics. We've talked about how we identify a function, right, with this open parentheses. We've talked about what an argument is, the fact that some functions take multiple arguments, and oftentimes functions have optional arguments that we can give them. There's one last piece that I want to talk about, and if you got all of this, then you're set, and you can learn R, and you're in great shape. But you might have noticed that there's something kind of frustrating about what I said, right? I told you that we give R instructions through functions, and that we identify functions with these parentheses. And you could probably think of some simple examples where we're giving R instructions and we don't have any parentheses. For example, 5 plus 6, right? And if we wanted to use that with variables or objects, we could have x equals 5 and y equals 6, and we could have x plus y. So we've given it 2 nouns, and we've given it a plus sign. So is that plus sign a verb? And the answer is yes. The plus is actually a function. So technically, most of the functions in R are what are called prefix operators. So that is when we type something like plot, the label of the function, plot, is the prefix, and then we've got our parentheses, and then inside of those parentheses come our arguments, arg1, arg2, etc., separated by commas. However, there are some special functions that are called infix operators, where the name of the function comes between the arguments and they don't use parentheses. So the plus sign is a really good example, x plus y, but we've also got things like x minus y, x divided by y, and even logical operators, which I'll be covering in my indexing tutorial, like x less than y. So in all of those cases, we're still giving our instructions through a function, it's just ordered really weird. And what's really nice is that technically we can actually still use those same functions as prefix operators. That is, we can identify them using the parentheses. If we put the grave signs, the backticks, which typically are to the left of the 1 key on your keyboard, if we put those around one of these infix operators, one of these special functions in R, then R treats it like it would a normal function. And so this here, the grave plus grave xy, is the same as saying x plus y. So actually, even though the syntax is a little bit different, R is very consistent in that anytime we're giving it instructions, we're actually using a function. In fact, even assignment, so even creating a variable, that is a set of instructions we're giving to R. Usually we use an equal sign or this arrow symbol. And those are also infix operators, which means if you wanted to be really roundabout, you could do something like this, where we might say values 10. And if we run this line of code, we now have an object called values that has an entry of 10. All right, so with that nerdy aside done, I've covered everything that you need to know about functions. Happy programming!